I hope Brock and Ceci were able to teach you invaluable information in regards to the history and safety of nuclear power plants. Welcome to the next step in the Dolittle presentation. My name is Garrett, and today I'm going to show you the basic operation of a nuclear power generation station. Nuclear power plants stand on the border between humanity's greatest hopes and its deepest fears for the future. In one hand, atomic energy offers clean energy. On the other, it summons images of disaster. It all starts on stage 1 of my slide, the cooling water condenser. This is located outside the containment shield, which are the big cement domes that are iconic to a nuclear station. The purpose of the cooling water condenser is to condense steam from the last stage in the power generation loop and collect all of the vapor in a basin, which is then cooled by a cooling tower through thermal exchange, which I will show a picture of later on in the presentation. After it is collected and cooled, it is pumped up to the steam generation tank, also known as stage 2. If you'll forward to the next slide, which is stage 2, the steam generator tank, which is located inside the containment shield. It acts as a heat exchanger for the nuclear reactor. In this stage, the generation tank will act as a tank that is heated up by the heat exchanger rods traveling from the nuclear reactor tank, in turn heating up the steam generation tank and creating steam, which will create pressure to drive the turbine and generator located outside of the containment shield, also known as the domes. All while doing this, it will also cool down the heat exchange rods, which will then return cooler water to the reactor fuel rods. With the water cooled down, which flows around the fuel rods, this will help to prevent a meltdown from overheating the fuel rods, which contain the uranium. And this is what happened in Japan, so that's why there were so many issues with nuclear expulsion over there. If you'll go to the next slide, we'll discuss what makes the power plant generate electricity. Simple answer is uranium and plutonium. It's a process known as nuclear fission, and it's all housed in the containment shield. Pictured here are 2 containment shields from the nuclear power generation station in San Onofre, California, located right on the coast of the Pacific, about 40 miles from my house. Inside these domes, it houses the heart of the power plant. If we'll go to the next slide, we'll discuss what is exactly inside of the domes. So uranium-235 is the most common element in the process of the nuclear power plant. Under nuclear fission, a nuclear reaction occurs within each nucleus. When bombarded with a neutron, it splits into smaller parts, often producing free neutrons, releasing very large amounts of energy and radiation, which in turn generates heat and operates the whole power plant. It is very, very important to monitor the fuel rods temperature to ensure that they are operating at a safe temperature to prevent a meltdown similar to what happened in Japan. The cooling tower is the last step in the whole process. Here it acts as an exchanger that runs through step 1, or the cooling water condenser, to cool down the vapor and water from the turbine. It does this via a water-to-air exchanger, which was pictured in the previous slide. It does this by allowing the hot water to reach the cool air in order to cool it down before it is pumped back into the stage 1 basin to cool stage 1 down. After it cools down the water from the water condenser, all the vapor is then expelled into the air, which lets off steam out of these taller steam stacks. The water from stage 1 is then pumped back into the containment shield to begin the process all over again. I hope you were able to understand the basics on how nuclear power generation system works, and want to wish everyone the best of luck in their future endeavors. I wish I was able to be more interactive with the slides because it would be a whole lot easier to understand, but unfortunately due to technical difficulties we have to resort to YouTube, so I appreciate your patience and have a great day.